Good day everybody. This question is already available on the social network and the author has given the solution to this question under the title Pretty GRE Integral. And what I feel is that the technique or the way approach followed by the author is a little bit long. So I wish to give an alternative method. You as a viewer can see both these techniques and you can take whichever that pleases your mind. So having mentioned that, let me move on. So what I wish to do is, questions like this always occur in competitive exams and there is no way to ignore that or to avoid that. So the best thing to do is to prepare ourselves. So that is imperative. So having mentioned that, what I wish to do is I would like to apply to solve this integral the King's property. So foremost, let me take this as let I be equal to integral 0 to pi x times sin x over 1 positive cos squared x. Now let me state the King's property. Suppose you got integral a to b f of x times dx, then my x will be replaced with a positive b negative x. So this is equal to integral a to b f of a positive b negative x times dx. So wherever you find x, you will have to replace it with a positive b negative x. Now this is a very powerful property and that's why it's rightly named as the King's property. With this property you can simply annihilate any complex integral. Of course there are a few restrictions and you will have to know where to apply, how to apply, when to apply. So having mentioned this, let me move on. So I wish to apply this King's property over here. And this is going to give me integral 0 to pi. Wherever x is found, I'm going to replace it with 0 positive pi negative x. So this is going to be pi negative x times sine of pi negative x divided by 1 positive cos squared of pi negative x times dx. Now there are a few things to evaluate. First, let me find out what is sine of pi negative x. This is equal to, I will be utilizing sine of a negative b formula, which is going to be sine a cos b negative cos a sine b. So this is going to be sine pi cos x negative cos pi sine x. Now sine pi is going to be 0, so this goes off. Cos pi is negative 1. Negative over negative will be positive, so this is going to give me sine x. So that is done. Let me come to cos squared of pi negative x. This can be rewritten as cos of pi negative x raised to the power of 2. Now what is cos of a minus b? Let me write the formula. Cos of a minus b is equal to cos a cos b positive sin a sin b. So we got cos of pi negative x, which is nothing but cos pi cos x positive sin pi sin x. Sin pi goes off, so cos pi is negative 1. So this is going to give me negative cos x. So I can rewrite cos of pi negative x to be as cos x with a negative sign. But that has to be raised to the power of 2. So that would give me positive cos squared x. Fine. So all of these workings are presented just to show that the outcome is cos squared x. So let me rewrite. This is equal to integral 0 to 1, it's 0 to pi negative x times sine of pi negative x. I found it out to be as sine x. Place that value. 1 positive cos squared pi negative x is found to be as cos squared x. So that is fine. So now distribute sine x and that would give me pi times sine x divided by 1 positive cos squared x times dx. The integration limits are 0 to pi negative x times sine x over 1 positive cos squared x times dx. Now what is this? This is nothing but my I. On the left I got an I, on the right I am also having a I. So this is going to be negative I, which is equal to integral 0 to pi times sine x dx divided by 1 positive cos squared x. So you can push the I to the other side and that would give me I positive I is equal to integral 0 to pi times sine x dx over 1 positive cos squared x. Now I need to make some substitution. Let me use a trick substitution of cos x is equal to t. I differentiate cos x, I get negative sine x dx is equal to dt. I need only sin x dx, so this is going to be negative dt. Now when x is equal to 0, what happens? T value will be 1. When x is equal to pi, t value will be negative 1. So substituting all of this, if I were to take this as 2, therefore my 2 is equal to, on the left I got 2 times I, integral, lower limit 0, I get 1, upper limit pi, I get negative 1, pi is here, so let me place that out. Sin x dx is negative dt, place that. 1 positive cos squared x, cos x is t, so it's going to be 1 positive t squared. Now if I were to change the limits to negative 1 to 1, the sign gets reversed, becomes positive. So this is going to be dt divided by 1 positive t squared. Now this function is an even function, so I can rewrite this as 2 times pi 0 to 1 dt divided by 1 positive t squared. Now what is this? This is nothing but tan inverse of t, and the limits are 0 to 1. So this is equal to 2 times pi tan inverse of 1 negative tan inverse of 0. Tan inverse of 0 is going to be 0. So I get 2 times pi. Tan inverse of 1 is pi divided by 4. So 2 divides pi, I should say 2 divides 4 2 times. So you get pi squared divided by 2. On the left you got 2 times I, but we need only I. So therefore I is equal to pi squared, push the 2 down, so you get 2 of 2, which is equal to pi squared over 4 units. So that is the solution for this question. Everybody, I hope you enjoyed this. Please consider subscribing and liking the video. Thank you.